Hello, this video is all about characteristics of function graphs. And we are going to start by identifying attributes of a function from its graph. We're going to look at positive and negative values. And when I say positive and negative values of a function, think about it this way. You know your function f of x, that's like saying y, right? So I'm looking for positive y values and negative y values. Increasing and decreasing intervals, so I'm going to be looking at increasing as in going that way and decreasing as in going that way. Turning points, which are local maximums and minimums, so if I had a graph like that, that would be your local maximum, and if it went down, that would be your local minimum. X-intercepts and zeros, which are essentially the same thing, but when we have a graph that crosses the x-axis, the x-intercept would be the point, and the zero would just be x equals a. So it's just a matter of the way you write it. And finally, average rate of change, because we may have a graph that's curving, and I want the average rate of change from here to here. Then I would, even though the graph is not completely linear from here to here, we could find a slope from there to there. Or if I wanted average rate of change from here to here, or from here to here. And so it won't be following the graph exactly, but we'll be basically finding the slope between 2 points on a graph. So here's an example that we're going to do. This is just a random function graph. We're going to use this graph and answer the following questions. First question, on which intervals are the function positive and negative is what that should say. So our positive y values would be all of the ones above the x-axis. That would be here and here and here. And our negative y values would be all the ones below the x-axis, here and here. So when it asks us to write the intervals, we are then going to be looking at this interval from this x value, which is actually negative infinity because it has an arrow, to here, and then this interval from here to here, and then this interval from here to here, and that interval, and that interval. So we're just going to break it down into the x values like this. It's positive from negative infinity to negative 2, and from negative 1 to positive 2, and from 4 to infinity. And I put soft brackets on all of those because when it actually hits that value, it's 0. And at 0, it's not positive. It's neither positive nor negative, so it's not inclusive. It's negative from negative 2 to negative 1, and from 2 to 4. Alright, next question, on which intervals are the function increasing and decreasing? And on this particular one, I had to kind of guess as to where, the exact points are. But I said this is increasing from about negative 1.5 to about 1/2, because that's where it's going up. And then from about 3.2 going up, and then infinitely. So it's increasing here and here. And then the decreasing, where it's coming down, from negative infinity to negative 1.5, and from 1/2 to 3.2, like that. Okay, where are the local maximums and minimums? Well, it only has one local maximum right there, and it has two local minimums, one here and one here. We say local because really this is the minimum, the lowest of the minimums, but that one's a local minimum because in that area where it is, locally, it's the minimum in that one area. Once again, on this graph, I had to kind of estimate where the points were. So the local maximum, I'd said it was about 1/2 and 3.2, and then negative 1.5 and negative 0.8 for that one, and 3.2, negative 3.5 for that one. Alright, next I want to know, what are the x-intercepts and zeros? So that would be where it crosses the x-axis. Here, 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 and here. And those points, if I wanted x-intercepts, if the problem says x-intercepts, make sure you give me ordered pairs. And those are negative 2, 0, negative 1, 0, 2, 0, and 4, 0. If I ask for zeros, I want x equals form. The zeros are at x equals -2, x equals -1, x equals 2, and x equals 4. And finally, what is the average rate of change from x equals 1 to x equals 2? So at x equals 1, we are right there. And at x equals 2, we are right there. So I basically want the slope from that point to that point. So all I have to do is say, okay, well that's going to be at about 1, 3, and that point's going to be at 2, 0, and I'm going to use the slope formula to find the slope. So the average rate of change from x equals 1 to x equals 2 is -3. Alright, now we're going to talk about modeling functions. When you have a set of data pairs x and y, you can make a scatter plot. You just plot all the points, and you can use that to determine what kind of trend the data follows. Maybe it's linear, maybe it's quadratic, maybe it's something else. So we're going to go over the steps using your graphing calculator for how to plot a scatter plot. So for right now, just write these steps down, and then I'm going to go through them in detail with an example problem. Okay, and then once you've done all these steps and you've got an equation that follows your data, you can use that equation to make predictions. And you've got two important vocabulary words here. If the prediction is within the domain of the model, we've got plots here, points all here, and I want to predict something, right about there. That's an interpolation. But if I want to make a prediction of something that's over here, outside of my domain, then that's an extrapolation. Another important thing that we need to talk about before we do our example is a correlation coefficient. And it's something you can get in the calculator. It's denoted by a little r. And it's a number from -1 to +1. And it measures how well the line, or whatever function you get, fits your set of data pairs. If r is near +1, then the points are very close to the line with a positive slope. If it's near -1, the points are very close to the line with a negative slope. And the closer that r is to 0, the further the points are from the line. So something like this might have a correlation coefficient of 1, whereas something like this would be a correlation coefficient of 0. Now, to see the correlation coefficient in your calculator, you're going to have to do a special little trick. You're going to have to turn the diagnostics on. You're going to press second catalog, which is right above the 0. And then you can either press the D button on the calculator or just scroll all the way down to diagnostic on. And then you're going to have to hit enter twice, and that will turn it on. And then when you do your stat calc, you will get the R value. And so when your calculator is giving you your, like say if you're doing a linear regression and you go stat calc linear regression and you get an R value near positive or -1, then you know, yeah, that line reasonably models my data. Alright, finally, I know you've all been waiting for this. Here's an example. Here's a table. Gives the average number of calories and total fat grams of the food served in various fast food establishments. So using your instructions that you've already written down, you're going to press Stat, and then you're going to choose the first option, Edit, and then you're going to put all of the X values in list 1 and all of the Y values in list 2. So the first thing I would have you do is, using your calculator, create the scatter plot and sketch the scatter plot. So remember, you're going to do second stat plot and turn it on, and then you can do zoom stat and take a look at your plot. That's what it should look like. Okay, after that, we're going to calculate the line of best fit using linear regression. So you're going to press stat, then you're going to arrow over to calc, and you're going to choose linreg. And it should give you this equation right here. Okay, after we do that, question is, what is the slope and what does it represent? So our slope, remember that's the m value, that's right here, and that's going to be 0.046. And the more important question is, what does it represent? So if you recall, slope is rise over run. So that means that the units of our slope are the y units, which are fat, and then over the x units, which are calories. So what that's saying is 0.046 over 1, there's 0.046 fat grams per calorie. And that's your increase. you have to say increase because that's an increase in fat grams per calorie of your food. And it's an average because obviously these points aren't exactly on that line. But you see it represents the increase in fat grams per increase of 1 calorie. Next question, what is the y-intercept and what does it represent? Well, there's your y-intercept, negative 1.179. So what does it mean? It means if x is 0, that means x is our calories, 0 calories, then there's going to be negative 1.179 fat grams. This is the projected amount of fat grams in a food with 0 calories. Sorry, I don't know why the words moved too. I say projected because I don't think that's really going to happen. If you have a food with 0 calories, like a glass of water, it's not going to have negative 1.179 fat grams. But once again, it's projected because we're finding an average rate of change here. All right, now what is the correlation coefficient and what does it represent? So when you did your stat calc linear regression, if you had your diagnostics turned on, you should get a little R value. Your screen ought to look like this. And don't worry about the R squared. Ignore the R squared. That's not something for us. That's a statistics thing that you'll learn if you take AP Stats. But R is our correlation coefficient, and it's 0.84669. So we're going to round to 0.847. Remember, always use 3 decimal places. And that's somewhat close to 1. It's not exactly 1. We can tell by looking at the picture that the dots aren't all following a perfect line. So we know it's not exactly 1, but it's close. It does indicate that the line is positive, and it does fit the data somewhat well. So I might ask you something now, like, if the calories of a food are 300, what would be the total fat? And you can now use the knowledge that you have to estimate how much fat a 300-calorie food would have. Suppose you went to, I don't know, Burger King, and on the menu it said what the calories were, but you're not counting calories, you're counting fat grams. Well, now you can kind of get a good idea. And the way you do that is just plug in. Y is my fat, so I'm looking for Y equals 0.046, and then X is the calories, so I'm going to put 300 in right here. And then plus 1.179, and I can calculate that. You should get about 14.979 grams of fat, so you can estimate about 15 fat grams. And another thing that you might be asked is, if the total fat was 25 grams, what would the calories be? So suppose you were in the other situation and someone told you the fat grams, but you were counting calories. Well, you would just plug in a 25 for Y, because that's where the fat goes, equals 0.046x plus 1.179. And that's why we practiced our solving for x skills in the past few days. We're just going to rearrange, solve for x. And the food should have about 517.848 calories. When you're answering questions, always give me 3 decimal places, please. Alright, now wasn't that a fun video? I want to leave you with this thought, though. I just taught you a whole bunch of stuff with the calculator, or reviewed it. You probably already knew it. But what if you didn't have a calculator? Could you still approximate a best fit line? You wouldn't be as accurate as the calculator, but yes, of course you could. And I want you to think about how would you do that all by yourself. All right, I'll see y'all tomorrow.